You know, that moment, right?
Yeah.
You just casually ask Alexa for the weather or maybe tell Siri to play that song you love and boom.
It just works
Yeah.
instantly.
Exactly. It feels, I don't know, almost like magic. This little device just understands you and delivers.
It really does.
Well, today on the deep dive, we're going to pull back that curtain. We want to explore, where do Alexa and Siri actually get their smarts from?
Yeah, it's a great question. And it's fascinating because, spoiler alert, most of that intelligence, it isn't really in that little speaker or your phone.
Right. And that's our mission today. We want to give you a really clear picture, sort of a mental map of that journey your voice takes from the moment you speak.
To getting that answer back or seeing the action happen.
We'll look at how they hear you, how they figure out what you actually mean, and then how they respond so well smoothly.
And like I hinted, a huge piece of this puzzle is cloud computing.
Mm.
Think like really powerful computers out there on the internet doing the hard work.
We'll keep it straightforward, promise. No drowning in jargon. Maybe even uncover a cool fact or two. Ready?
Absolutely. Let's start right at the beginning. How do they even know we want to talk to them in the first place?
Okay, yeah.
Yeah.
So the first thing is your assistant is kind of always listening, but only for one specific thing, that wake word.
Alexa, hey Siri, whatever it might be.
Exactly. It's like calling someone's name across a room trying to get their attention. The microphone is picking up sound.
But, and this is key, it's not constantly sending all that audio somewhere else.
Right. There's a tiny bit of software on the device itself that's just listening for that one sound pattern, that wake word.
It's super efficient, that local recognition, just waiting for the trigger, like a password.
Totally. And only when it hears that word Alexa does it activate. That's the activation moment.
Okay, now it's listening, ready for the command.
Precisely. And at that point, would you say next, your actual request, like, Alexa, what's the weather today in my city? That gets recorded as audio.
But here's where the device kind of hands things off, right?
Yes. This is where the cloud really steps in. Your
Hmm.
speaker, your phone, it doesn't do the heavy lifting of understanding language right there.
No way.
It takes that audio clip, packages it up digitally, and sends it over your internet connection.
Needs that Wi-Fi.
Absolutely needs it. It sends it off to the cloud, those giant server farms run by Amazon or Apple.
So if your internet's down,
You're pretty much stuck. Because that line to the cloud brain, as we're calling it, is cut.
for Alexa, that's Alexa Voice Services, AVS. Siri sends it off to Apple servers.
So basically, it hears its name, hears your question, puts it in a digital envelope, and mails it to the super smart internet brain.
Okay, so this internet brain, the cloud, let's unpack that a bit more. What is it really?
Well, when we say the cloud, we're talking about incredibly powerful computers.
Mm.
Think massive data centers.
Warehouses full of servers, blinking lights, humming machines.
Exactly. And the genius is, by relying on these, Alexa and Siri don't need, a supercomputer crammed into that little device on your counter.
Right, all that really intensive processing, the heavy lifting, it happens remotely on these servers that have just vast resources.
So the device itself, it's more like a messenger, a fancy walkie-talkie almost.
Yeah, it sends the message out, gets the process response back.
Precisely. It sends your voice, and then in the cloud, this whole sequence of really complex AI processes kicks off super fast, usually just a second or two.
So what's the first step once that audio arrives in the cloud?
First step is hearing,
Or
or more technically, figuring out the exact words you spoke.
right, and that's automatic speech recognition, ASR. You can think of it as the cloud's giant, highly trained ear.
Trained on just tons and tons of human speech.
Exactly. Its job is to filter out background noise, maybe the TV, the dog barking,
And zero in on your voice. Then it uses sophisticated algorithms, AI, machine learning.
to turn those sound waves into actual text. So, Alexa, what's the weather today in Warsaw? Becomes the written words. What's the weather today in Warsaw?
And this isn't simple stuff. Early systems tried matching sounds too, like basic units called phones used statistics.
But modern systems, they use deep learning, neural networks. Think complex brain-like structures.
Which makes them way better, right? With accents, noise.
Oh, much better. They can handle a huge amount of variation. It's like a really attentive listener who gets you even if you mumble a bit or talk quickly.
And they do learn, don't they? Get better the more voices they hear.
Absolutely. Constantly improving. But okay, end of step one. The cloud now has your request as text. What's next? It needs to understand the meaning.
Exactly. Understanding. That's natural language processing, NLP. This is about teaching computers human language beyond just words. The nuance, the intent.
It's like the system becomes a sentence detective. Analyzing the text.
To figure out your intent, what you actually want to do, and the key details, the entities.
Right, so if you say, set a timer for 10 minutes.
Intent, set timer. Entity, 10 minutes.
Perfect. Or, what's the weather in Paris tomorrow? Intent. Get weather. Entities. Paris, tomorrow. It pulls out the crucial bits.
It considers context, too, right? Like if music is playing and you say, skip this.
Yeah, it knows this means the current song. It's not just isolated sentences. There's some complex linguistic stuff happening, breaking down sentences, grammar.
Using huge language models, basically libraries of text, to figure it out.
So if ASR is the hearing part,
NLP is the thinking about what was heard part.
makes sense. So by now, the cloud service gets what you're asking. What does it do then?
Well, now it has to decide how to fulfill that request. The best way to get it done.
Like a super efficient assistant mapping out the task.
Exactly. If it's a question like what time is it or who's the first president, it'll likely look it up. Databases, maybe the web.
It might use an API, like a direct line to another service. For weather, maybe AccuWeather or something similar.
Yeah. Gets the data straight from the source. For facts, maybe Wikipedia or a search engine result.
That's why sometimes Siri says, here's what I found on the web, right? It did a quick background search.
Totally. Now, if it's a command, turn off the lights, play Bohemian Rhapsody.
It needs to connect that intent to a specific capability.
Right. Think about Alexa's skills. There are over 100,000 of them.
Wow. Like little apps for specific tasks.
Exactly. A smart home skill talks to your lights. A music skill talks to Spotify or Amazon Music. So Alexa figures out, okay, user wants lights off, and talks to the smart home skill.
And for Siri on your phone, it might trigger the Messages app to send a text or the Music app.
Yep. So basically, the cloud brain decides the best path. Look it up, ask another service, or trigger an action.
Okay, decision made. Now for the actual doing. Fetching the answer or executing the command.
Right. The cloud assistant now actually goes and does it, queries that database, calls that weather API, retrieves that fact.
Connects to Spotify or Apple Music to start the stream.
Or sends the signal over the internet to your smart light bulb.
That communication often uses secure APIs or specific protocols for smart home stuff. The Internet of Things.
And if it's answering a question, it puts together the response. Sometimes using fancy AI to sound natural, sometimes maybe just filling in a template.
Like it gets raw weather data, 18 degrees sunny, and turns it into, today in Warsaw, it's 18 degrees Celsius and sunny.
Exactly. So, end of this stage, the action's done or the answer is ready. How does it get back to me?
That's the final leg, the return journey. The response travels back down the internet highway to your device.
Your speaker, your phone, whatever you asked, like a boomerang coming back.
And once it arrives, your device either does the thing lights off, or, more often, it speaks the answer.
And that voice, that's text-to-speech, TTS. The cloud took the text answer.
Looks like rain today, grab an umbrella.
And turned it into an audio file in that familiar voice.
And those voices are getting so much better, right? Not robotic like they used to be. They use AI, neural networks to add intonation, rhythm, make it sound more human.
Definitely. Or if you ask for music, the device just starts playing the stream it received. The cloud told Spotify to send the music directly to your speaker.
And for commands like setting a timer, the device starts the clock and might say, okay, 10 minutes, starting now.
So it's really a team effort. Your device and the massive brain and the cloud working together. It happens so fast, it feels seamless.
It really does. Which brings up that big question. Why bother with the cloud at all? Why not just do everything on the device?
Oh, yeah. The simple answer, power and data, just sheer scale.
Understanding human language, accessing basically all the world's information, that takes huge computing power.
Way more than you can realistically cram into a little smart speaker or even your phone, especially without draining the battery instantly.
Exactly. The cloud gives Alexa and Siri access to, effectively, a supercomputer whenever they need it. These data centers have incredible processing power, massive memory, huge databases.
They can run those really complex AI models that just wouldn't fit or run properly on your local device.
Plus, think about updates. If the AI team makes the speech recognition better,
they update it on the servers, and boom. Every Alexa and Siri instantly gets smarter.
You don't need a new device or even necessarily a software update on your end. It's continuous improvement, centrally managed.
And the real-time info. News, sports scores, your calendar. It needs that live internet connection anyway.
So the device acts like a bridge, connecting you to all these internet
It's
resources.
like having a super helpful concierge.
Yeah.
You ask for something complex,
They don't know everything themselves, but they know exactly who to call or where to look to get the answer for you fast. The real smarts, the how-to, lives in the cloud.
okay, so we talked about the request going up,
Yeah.
processing happening, but that return trip is just as crucial.
Absolutely, that boomerang effect.
Hmm.
The answer or the instructions come flying back down the internet pipe.
Back to your device.
Yep. And your device then presents it. Maybe speaks the answer using that TTS voice.
Or starts playing the music stream it's receiving.
Or flips the switch on your smart plug, maybe with a quick OK confirmation.
Let's make it concrete. Walk through an example. Say, Alexa, play some upbeat pop music.
Okay. Step 1, your Echo hears Alexa, light ring comes on, activation.
Right. Then, the audio of play some upbeat pop music goes zooming over your Wi-Fi.
To Amazon's cloud servers, AVS.
In the cloud, first ASR kicks in,
Yeah.
turns that audio into text. Play some upbeat pop music.
Then NLP analyzes that text. Intent, play music. Entity detail, upbeat pop genre. It figures out what you want.
It probably checks your linked music services, right? Like your default Spotify, maybe?
Yeah, most likely. Then the Alexa cloud service talks to, say, Spotify service. Tells it, user wants upbeat pop.
Spotify finds a playlist or station.
And instead of sending text back, it sends instructions to start streaming that music.
And those instructions, plus the music stream itself, come back down to your Echo.
And suddenly, pop music is playing. You might even hear Alexa say, now playing upbeat pop on Spotify just before it starts. That's the TTS confirming.
And, like we said, if your Wi-Fi cut out mid-request,
You'd get that dreaded, sorry, I'm having trouble connecting message. It really shows the dependency.
one more thing that's super interesting is how they learn. They get better over time.
Oh, yeah, definitely. It's not static. Machine learning is constantly at work. Do
Yeah.
you ever get asked, did that answer your question?
Yeah, sometimes. Or you can rate the response.
That feedback is gold. It helps train the AI models. Your yes or no helps it learn.
It learns from millions of interactions, figuring out common questions, how people phrase things.
But even your personal preferences. If you ask for the weather every morning at 7 a.m.
It might eventually just offer it proactively.
Exactly. Or suggest contacts you call often at certain times, it starts anticipating.
And again, that learning happens in the cloud. The more data the AI models process.
The better they get at understanding and responding. And those improvements benefit everyone because the core intelligence is server-side. It's like Netflix learning your taste in movies.
Okay, we should probably briefly touch on privacy, even though it's a whole other deep dive. People do worry about microphones listening.
It's a valid concern. Recordings are going to the cloud. Companies say they use encryption, offer deletion options, try to anonymize data.
And the wake word system is designed so it only sends audio after it thinks it heard the trigger word.
Right. It's not supposed to be constantly streaming everything, but fundamentally, you are sending your voice data to external servers.
It's a trade-off, isn't it? Convenience versus trusting the company with your data. Something to be aware of.
Definitely. It's part of how they get smart learning from user data, but raises important questions.
Okay, so let's wrap this up to bring it all together.
Yeah, the bottom line is Alexa and Siri's smarts. It's this blend of the device hardware, the software.
And crucially, that massive brain power in the cloud. The gadget you see is just the front end.
Behind it, you've got sophisticated voice recognition, really advanced natural language understanding, and AI tapping into the internet's vast resources.
It goes back to that analogy, maybe. The student with the earpiece connected to a supercomputer.
Exactly. The device looks smart, but the real power is external. The cloud is the secret sauce.
It's how this simple-looking gadget can access almost anything, control things, have conversations. It's leveraging resources way beyond itself.
So next time you ask Alexa for a joke or get Siri to set a timer,
Just picture that quick journey. Your voice going up, getting processed by serious AI in some distant data center, and the answer zipping right back.
tiny device, huge brain in the digital sky.
And that, really, is where they get their smarts. Listening, leveraging the cloud, and constantly learning. So thanks for joining us on this deep dive.
Hope it gave you a bit more appreciation for what's happening behind the scenes.
Yeah, maybe something to impress your friends with. Remember, it's not magic.
It's a direct line to incredible computing power, made simple by a wake word.
How cool is that?
Yeah.
We'll be back with more Tech Explainers soon. Until then.
Just say the word, and your helpful digital friend in the cloud is listening.